Look at problem number 5 in section 4.7. We are asked to find the inverse cosine of 1/2. When you look at a problem like this with the inverse function, read this as find the angle whose cosine is 1/2. In these problems, you need to think in terms of a triangle. This is the angle theta. The cosine of theta is x over r. The sine of theta is y over r. The tangent is y over x. Get this triangle in mind and get away from thinking SOHCAHTOA, adjacent, hypotenuse, and get this vision in mind. So if we're looking at the angle whose cosine is 1/2, we know that the cosine of the angle is x over r. If x over r equal 1/2, x equal 1, r equal 2. If I draw this and put x equal 1, r equal 2, I recognize this immediately as one of the three triangles that we discussed. This side is 1, that side is 2, this has to be the square root of 3, and the angle theta is a 60-degree angle, or pi over 3. Remember, there were three angles we discussed. A 45-degree angle has 1 square root of 2. This is pi over 4. A 30-degree angle has 2 square root of 3. That's a 30-degree angle. A 60-degree angle is just this corner of that triangle, but it would have 1, 2, and the square root of 3. Look at problem number 7, the inverse tangent of -1. Read this problem as find the angle whose tangent is -1. Inverse tangent says return the angle whose tangent is -1. Think of the triangle again. We have an angle. We have the tangent is y over x. So I know the tangent of theta would be y over x. Y over x is going to be equal to -1 over 1. If I think about that, I have y equal -1. I have x equal +1. And once again, remember our three triangles. If I have 1 square root of 2, then this makes a 45-degree angle, or pi over 4. In this case, though, it is a negative angle, so the answer is minus pi over 4, or minus 45 degrees. You might be tempted to say, well, how do I know that isn't 1 over -1? Because that would also be equal to a -1. Why can't I say y equal 1 and x equal -1? If we did that, we would have x equal -1 and y equal 1, and we would have this angle. So your question is, how do I know it isn't that angle? Because the tangent function is only defined between minus pi over 2 and plus pi over 2. It is not defined for quadrants 2 or quadrants 3. So therefore, this would not be an acceptable solution because it does not appear from minus pi halves to plus pi halves. Problem 21 says y equal the arctangent of x squared. It wants to know the limit as x goes to infinity and x goes to minus infinity. We can write this equation as the tangent of y is equal to the tangent of this tangent -1 of x squared. In other words, just take the tangent of each side. Then I have the tangent of y is equal to the tangent of the arctangent. These are inverse functions, will just return whatever is here. So that's going to return x squared. So I have x squared is equal to the tangent of y. Y, since it's the tangent of y, must lie between minus pi halves and plus pi halves. But I'm seeking for x squared. So that is going to force the number to always be positive. Therefore, the limit as x goes to infinity of this function up here will be pi over 2. Because if you look at the function, the tangent looks like this. The tangent of x squared is going to be much sharper on this side like this. What might be confusing, and think about it for a minute, as that x approaches minus infinity, y equal tan minus 1 of x squared, is also pi halves, not minus pi halves, because x always is positive. So therefore, the only way, as x grows larger, y has to approach pi halves, because x is only growing larger in the positive sense because it's x squared. So in both cases, the limit is pi over 2. Look at problem number 22, y equal the arctangent of x squared, whole quantity squared. Take the square root of both sides. I would have plus or minus the square root of y is equal to the arctangent of x. Now take the tangent of both sides. I have the tangent of plus or minus the square root of y is equal to the tangent of the arctangent of x. Tangent and arctangent are inverse functions. So when one operates on the other, it is simply going to return x. Therefore, tangent plus or minus the square root of y is going to be equal to x. Since we're taking the square root of y, y must be positive, so it can only go from 0, and we're taking the tangent of that has to be the square root, to pi squared over 4. There are several ways to look at how to think about the solution now. Here's the tangent. Plus pi over 2 to minus pi over 2. The tangent looks like this. This is x, this is y. If we do the arctangent, we flip the axis around this way and reflect, and if we were plotting the arctangent here, we would get a function that looks like this, where we're approaching pi halves minus pi halves. If we square the arctangent, then we get a function that looks like this. Or now I'm approaching pi over 4. So, as x approaches positive infinity, of this function, I get pi over 4 as a limit. As x approaches negative infinity, this term is always squared. When x approaches negative infinity, that term is always squared. So y cannot be negative. So as x approaches a negative infinity, I also have the limit to be pi over 4. So in both cases, the limit is plus pi over 4. Problem 29 is find the arcsine of the cosine pi over 3. This is usually written sine minus 1 cosine pi over 3. Let's look at problem 29, the arcsine of the cosine pi over 3. This is usually written as sine minus 1 cosine pi over 3. Pi over 3 is 60 degrees. This is one of the angles we learned. This is 60 degrees. That side is 1, that side is 2, that side is the square root of 3. The cosine pi over 3 will be x over r. And that is 1/2. So this particular part, the cosine pi over 3 is 1/2. Now I'm left with the inverse sine of 1/2. Read this as return the angle whose sine is 1/2. The sine is going to be y over r. So if this is 1/2, it says y is equal to 1, r is equal to 2. That means x is the square root of 3. When we go back, this is one of the triangles we learned, and we know that is 30 degrees or pi over 6. So the arcsine of the cosine of pi over 3 is pi over 6. Problem 31 says find the cosine of the arctangent of the square root of 3. The arctangent of the square root of 3 says find the angle whose tangent is the square root of 3. The tangent is y over x. This would be square root of 3 over 1. So if y is going to be the square root of 3 and x is 1, then r has to be 2. This is our familiar triangle again of 60 degrees, or pi over 3. Therefore, the arctangent of the square root of 3 is pi over 3, and I'm left with the cosine of pi over 3. I already have my triangle for pi over 3. The cosine is x over r. So the cosine of pi over 3 is equal to 1 over 2, and 1/2 is my answer.